Hello everyone, it's Angela, and today we're going to be going over the first problem on your pre-Thursday workshop, continuing our ventures with ice tables. Now, as I read the problem, of course, I'm going to be highlighting the important information. So, we have a hot mixture of three gases, acetylene, oxygen, and carbon dioxide, and they're all allowed to react. And we are asked to find the initial amount of CO2, the limiting reactant, and the percent yield. And there's a note that we do not need to complete all the boxes. Now that I've gotten the facts, read the question, let's go in and fill out our ice table with the things that we can deduce. So the first thing that we have is that we have a hot mixture of three gases, acetylene, oxygen, and carbon dioxide. But notice that carbon dioxide is actually a product. So we have a mixture of two of the reactants with the product. But there's no word on H2O. And so because there's none stated in the initial, I will designate this as 0 moles. And now let's look at our ice table. We have an initial of 0 moles. We end with 4 moles. So we know that we have a change of +4. And so I'll write that in our change question mark line. And I'm doing this because our change question mark line represents what actually happens in the equation. And our change 100 represents what would theoretically happen if everything went perfectly and it went to full completion. Now that we have this +4, we can see how the other compounds are related to H2O and solve for their changes. So from carbon dioxide to water is a 4:2 ratio. And so this is going to be +8, plus because it's a product. From oxygen to water is a 5:2 ratio. So if you take that into account, this will be a -10, minus because it's a reactant. And for acetylene, it's a 1:1 ratio. So this is also going to be -4. So now we have all of our change question mark lines filled out, so we can find the initial values for each of our species. For acetylene, if we end with 6 moles and had lost 4 moles, that means we had initially started with 10 moles. For oxygen, if we had lost 10 moles, if we had ended with 20 moles and had lost 10 moles, that means we had started with 30 moles. And for carbon dioxide, if we had ended with 16 moles and had gained 8 moles, that means that we started out with 8 moles. And as you can see, highlighted in pink, we were supposed to find the initial amount of CO2. And that has now been solved. Now, the next thing that we want to do is solve for the limiting reactant. And we can do that by finding the mole reactions of our reactants, acetylene and CO2 and O2. And this will go right here above these boxes. And you find the mole reaction by taking the initial amount divided by the coefficient in front of our reactant. So for acetylene, it has 5 mole reaction. And for oxygen, it is 6 mole reaction. So because acetylene has a smaller mole reaction, it is our limiting reactant. So I will highlight that because we have solved for this. And now that we know that acetylene is our limiting reactant, we can put in its change 100 line of minus 10, because as the limiting reactant, all of it would be used up in a theoretical perfect situation. The final thing that we need to do is solve for percent yield. Now, the percent yield is commonly the actual thing that occurred in the experiment over the theoretical of what would occur in the experiment. Now, in this case, our actual is our change question mark, and our theoretical is our change 100. So our percent yield is going to be 4 divided by 10, otherwise 40%. And that is our final answer. Everything has been addressed. We didn't fill out all the boxes. And overall, that is our video for today. I hope you found this helpful. Thank you so much for watching.